Compiling C code. What does that mean? Why do you need to do that? Well, in my case, I wanted to learn how to compile the firmware for the HackRF SDR after I replaced the blown LPC chip on the board. And yes, you can use release files if they exist, but sometimes you only have source code to work with, and if you make changes to the original code, you would need to recompile it. So in this beginner-friendly demo, we'll learn how to compile the HackRF firmware from scratch. We're going to use Linux Mint as the environment, and there's no experience needed. So this doesn't only apply to firmware, but you can compile any code that's written in C or C++. So here's what we'll do. We will set up the tools the computer needs. We'll download the source code. I'll try to explain what's happening along the way, and finally we'll turn it into working firmware files that we can actually use. So let's get started by opening our terminal window. I'm going to drop you there, and I'm going to open a file browser. I'm going to drop you there. I'm going to open a web browser as well. And the only pre-prep I've done for this is dropped a link here for Great Scott Gadget's HackRF. This is the creator of the HackRF SDR. So we're going to use that code for the demo. Alright, first up, we need to install Git. So Git is a version control system, and it helps you track changes in code. You can collaborate with others. It's got a variety of uses, but we'll be using it to clone the GitHub repositories for the files needed for this demo. So with that said, I'm going to just start off with a sudo su, and I'm going to put my password in, which is glow, don't say anything. And let's go apt install git. Yes. Alright, seems to be fetching Git for me, and there it goes, happy, and that seems to be done. Next we will install Cmake, so that's also apt install Cmake. So Cmake is a cross-platform tool. It helps you build C++ code by generating the build files, the native build files. It can also help developers ensure that their code compiles correctly across different operating systems and compilers. I think in short, Cmake just sets up the build, and the compiler does the building. So let me give that a yes. And while that's going, next up will be Python 3-YAML, YAML. Now I actually think Linux Mint has this pre-installed. Let's have a look. Python 3-YAML, and it does indeed. But what that is, it's a Python library, and it helps your Python 3 programs, it allows your Python 3 programs to read from and write to YAML files. Now YAML is a popular data serialization language. I know that's a lot there, data serialization language. And it's used mostly for like writing configuration files, I think. I'm not 100% on YAML, but I know I think it stands for YAML Ain't Markup Language, which is in itself a recursive acronym, but we're not going to get into that here. So that's already done. Up next would be the GCC ARM toolchain. So that is, excuse me, apt install gcc-arm none eab, and I'll explain this now. Give that a yes. So this is a tool chain used to compile code for ARM-based microcontrollers that don't run an operating system, hence the none. And EABI, or EAB as I call it, is Embedded Application Binary Interface. Another big one there. But this includes the compiler, that's the GCC part, an assembler, a linker, and some other tools. And I think it's specifically built for developing bare metal firmware for like ARM devices, like low level, no OS type of thing. And what's going on here? It's taking a while. That's really taking a while. Okay, there we're done. Okay, now we'll head on over to the web browser and just go back to the HackRF page that's already open, and we're going to clone this page. So what I'm going to do is just copy that address, go back to my terminal. I'm going to git clone. I think we need the HTTP. Let me just see what this pastes. It does indeed paste the HTTP. Alright, so you can just copy and paste the web address, but we need to add a .git to the end. So that's going to clone into a new folder called HackRF. And there, it's already done. That was nice and quick and convenient. Alright, next up we need to go back to the web browser and we need to clone another repository in GitHub. And this one is from a user called Mossman. Lib open cm3 So this is a fork of libopencm3, which is an open source firmware library for ARM microcontrollers, ARM Cortex-M microcontrollers. So it provides low-level access to the hardware features for various ARM chips, like the STM32 or the LPC IC that we're working with, or that I worked with. And it does this without relying on like proprietary vendor libraries. So I'm going to copy that and we're going to go back to our terminal. Git clone, paste, add the .git to the end, and that'll clone into its own folder as well. And that's already done, nice and quick. So now that we've got those repositories cloned, we can navigate to the first directory to continue. So we have our two new directories over here. And I think we'll be working in firmware. HackRF USB. But anyway, back to the terminal. We can change directory to that folder, so cd HackRF. And I'm just going to do this all in one line. So the next one is firmware, and then we have HackRF_USB. Okay. Next step, we're going to open, or not open, but we're going to include that libopencm3 library as a submodule in this HackRF project folder, but it doesn't fetch the code yet. So I'm going to type in a git submodule, init, initialization, and that's done. Now we're going to fetch and check the libopencm3 code required for this HackRF project. So similar command, but instead of initialization we're going to go update, and this adds all the files needed, and it's done, nice and quick. So now that we've got the submodule in place and updated, we can proceed to creating the build or the output folder where our files will be created in. We can just go make directory, mkdir build. It's going to create the build folder. It's just popped up on the right hand side here. Now we need to go into that build folder, so that's cd build. Okay, you'll see this build folder is empty at the moment. What we're going to do now, next command is cmake. Remember that from right in the beginning. This command is cmake space dot dot. The space is pretty important. So what this command does or tells is it generates or tells Cmake to generate the build files using the configuration file found one directory up, the firmware directory, and specifically it looks in that directory for a cmake list.txt file. It reads the build configuration like the source files and compiler settings, and then it generates the build files like makefile in the current directory. So it was pretty quick, but now you can see we've got a few things added into this folder on the left hand side in our file explorer. Back to the terminal, almost done. Next command is make, just as it is, and this will take about a minute or so, but this is creating all of the firmware files and bin hex files, whatever the config tells it to make, really. So you can see we already have a few bin alf files. Do we have any hex files in there? I don't see any hex files, but we have bin and we have some alf files. So there we have it, a bunch of new files created and ready for use. For my use case, I would use only one or two of these files, but if if you've read the documentation and you know what you're dealing with, you'll know which files you need to work with. And I'm talking in respect to all of these others, specifically for this HackRF project. So hopefully that helps someone out there. That's it for now. Hopefully it was quick and easy. So I'll catch you at the next repair, or whatever it turns out to be. Later.